So, when we talk about energy, there's usually two different terms that tend to come up a lot, and that's kinematic energy and potential energy. Probably wondering, how do those things relate? And actually, the combination of kinetic energy and potential energy actually is mechanical energy, which is a total. Anyway, so kinetic energy is energy of motion. So basically, if something's moving and it's doing work, then it has kinetic energy. Potential energy is stored energy, so it has a potential to do work. So it could become kinetic energy, it could become any other kind of energy, but as of now it isn't. It just has the opportunity to. It's like, I could go get a job, but I'm not right now. Whereas if I actually am doing a job, then that would be kinetic, if that makes sense. So, as I said before, if energy kinetic plus your energy potential is equal to your mechanical energy. So, saying that, you can have both kinetic and potential energy at the same time. You can have just one or you can have just the other. So, a little bit of example. Let's say you have a rock. You place it at the top of a hill. Can you picture this? So you have this big rock at the top of the hill. It's not moving, it's just sitting there, at the edge of a cliff, let's say. So that has potential energy because it has the potential to do work if it started, right? It's right on the top of a hill. If it started rolling, it would be doing kinetic. It has a potential to do work. So, let's say this rock starts rolling. If we're not holding it up at that point, I guess we would have to be holding the rock up. So we finally let go of this big boulder. It starts rolling. It has potential energy and kinetic energy. It's moving, but it still has the potential to do more. Okay, so then at the very end, at the very bottom, it's just moving everything. There's no more potential energy because it's finally it's on its last leg. So that's the very end of its movement. So it has no more it can give. All kinetic energy. So, once more, top of the hill, potential, rolling down, both, the very bottom, kinetic. Now, if we take into account the conservation of energy, then we can assume that the same amount of energy at the top will be equal to the same amount at the bottom. So, the total amount of potential is equal to the total amount of kinetic. And by doing that, we can actually figure out how much is at each individual stage. If we know one, it'll add up to the total. So if I know the kinetic energy halfway down the hill, I can figure out the potential energy halfway down the hill because I know the total energy. Another really key important thing when they're talking about potential and kinetic energy is that with potential energy, it doesn't matter what path it took to get there. So if I'm holding a rock and